This video is the first lesson in the Basic Algebra in Full series. To access all lessons in this series or playlist, check the video description and pinned comments. Happy studying. In this first lesson, we will talk about algebra, basically introduce it, then explain clearly the terminologies we see in algebra, like constants, variable, expressions, like terms, coefficients, and so on. And finally, we will introduce that skill of converting word problems to algebra. And then you now understand why algebra is called the language of mathematics. Now, look at this question on your screen. 90 people were at an event. Some left while 50 remained. How many people left the event? This is pretty straightforward, right? You just say 90 minus 50, which gives you 40. But what if it wasn't as straightforward as this? What if we had, as you see on your screen now? So now it says some left. Twice the number that left remained. How many people left? Definitely this is more difficult. How do you solve it? Since you don't know the number of people that left and the number of people remaining, so you say if the number of people that left is x, then the number of people remaining will be 2x. That is 2 times x, since it says twice the number that left remained. This is basically what algebra is. So here you are trying to use the letters to replace or represent the missing numbers so that you can still maintain the same mathematical process you would have used to solve the problem. So algebra is investigative mathematics. That's basically what it is. So if we wanted to define algebra, we would just say that it is when you use letters in mathematics. That's why it's called the language of mathematics. So before we continue, let's quickly use this and explain something. What we've written here is called an algebraic equation. Why is it an algebraic equation? Because algebraic already, because it has a letter in it. Equation, because it has the equal to sign here. But if we remove this equal to here, then it becomes an algebraic expression. So that's the difference between an algebraic equation and an algebraic expression, just the equal to. Now, let me quickly mention two things here. For those who do not understand how we came about the x and the 2x, don't bother yourself yet. The aim of this part is not for you to know how we got x and 2x. It's just for you to know that those equations and expressions you see every day, x, 2x, a, b, y, and so on, this is how they come about. In fact, at a point, you'll be able to create your own equations from word problems, which we'll touch as the lesson goes on. Also, what happens next after you've gotten your x, 2x, y, a, whatever, in the form of an equation or an expression? How do you go about it to get the answer? That is what this entire series is all about. From lesson 1 to lesson 10. We are going to go through everything step by step. So just make sure you follow all the videos in order for you to understand it properly. Now let's talk about some of the terms you will hear in algebra. Let's write a clear equation or expression, 2x plus 3. Now in this expression, we can see that there is a letter here which is representing a missing number. Because this letter can be any number, it is called a variable. So every letter in an algebraic statement, whether expression or equation, is called a variable. Now, the number that is just beside that letter, like a companion, is called the coefficient. The coefficient of that variable. So coefficient of x, coefficient of a, coefficient of b, whatever the variable is. Then the other number that doesn't have any letter accompanying it, or that it is accompanying, is called a constant, because that number will not change in that equation. Whatever it is what it will remain. Then the final participant of an algebraic statement, whether expression or equation, is this plus sign here. It can be plus, can be minus. It's called an operator. Okay, so these are the typical participants of an algebraic expression or an equation. The next thing we are going to look at now is terms, like terms, unlike terms. And to do that, we are going to use something a bit longer, an expression that is a bit longer. So look at this expression on your screen now. Identify the operators first. From what you said, plus, plus, minus here are all operators, right? So a term just means anything that is on either side of the operator. So an operator separates one term from another. Also, the equal to sign separates one term from another. What do I mean? This 2x here is a term. 3 here is a term. 5x here is a term. 6y here is a term. And then 3 is another term. So these are all the terms in this algebraic expression. If we had, say, equal to 7, then this 7 will also be a term. As I already said, the equal to sign also separates one term from another term. Now, when we say like terms and unlike terms, what do we mean? Like terms means which terms are alike. So from what we see here, 2x and 5x are alike. So they are like terms. How are they alike? They are alike because they both contain x. And the x they both contain has the same power. It is not x raised to power 2. They are both x raised to power 1, x raised to power 1. So they are alike, so that they are called like terms. Now, from this explanation, you already figure out what unlike terms are. So something like 5x and 6y will now be unlike terms because they have two different letters. One has x, one has y. 6y and 3 will also be unlike because one has y, one doesn't have any letter. Same thing with 2x and 3. They will be unlike also. So this is what like terms and unlike terms are. You may be wondering, why are we saying like terms and unlike terms? You need to know what like terms and unlike terms are, because you need that knowledge to be able to group these terms together, to be able to solve or simplify the algebraic expression or equation. That's like the first thing you must do before you continue your simplification process. So that's why it's important to know them, as you will see when we get to lesson 2. So the next thing we are going to look at, which is the final part of this lesson, final section, is we are going to introduce word problems, or how to create your own algebra from statements, like normal statements of day-to-day living. We will still do a lot of this when we get to the final lesson, lesson 10, but this is just a way of introduction. So what we will do now is that we are going to start with some small statements, some of those things that you see all the time, so that you'll be able to know that when I see this, it means this. So let's take them one after the other. We'll take the first one that will be on your screen now. So we see the first one. A number increased by 5. So just simple reading and understanding. A number, what is that number? You don't know the number. So let us say the number is y. So that number increased by 5. What does it mean to increase by? Plus 5. That's all. So this is the algebraic equivalent of this statement that we just see now. You see how simple it is? Let's take another one. So this is another one. Twice a number. What does twice mean? Twice means 2 times a number, which we don't know. So let's say the number is y. So 2 times y. Simple, right? Let's look at another one. A number decreased by 3. Decreased by a number. We don't know the number. Decreased by, when something decreases, that is minus 3. Simple. Let's take another one. Now this one is a bit more word problemy, kind of. Paul's age is twice that of Mary. So how do you represent Paul's age in algebra? How do you translate this statement? Now this one is a bit more difficult than what we've been doing. Paul's age, we don't know Paul's age. So, but what we know is that it is dependent on Mary's age. You see how I'm trying to get the logic. Now, what is that Mary's age that Paul's age is dependent on? We don't know. So let that Mary's age, let it be, say, X. So if Mary's age is X, then Paul's age is twice that of Mary. That means that Paul's age is 2 times X. That's all. As simple as that. Let us take another one, even more difficult or something similar. Now see this one. Paul's age is 2 more than Mary's. Again, easy, just like the last time. Paul's age is dependent on Mary's age. Since we don't know Mary's age, we can't know Paul's age. So Mary's age has to be what we are looking for first. So let's say that Mary's age is Y. So if Mary's age is Y, then Paul's age is 2 more than, that is 2 plus Y or Y plus 2. Again, very simple. Let's take another one that is even more difficult and probably we'll call it the end of the video. Now this one is more difficult, the most difficult out of everything we've done so far. Paul is twice as old as Mary. So see, for this question or for any algebraic statement, remember what I said. For every word problem or verbal statement you want to convert into algebra so that you can find the solution. The best thing to do is to read it in steps. Any part you understand, write it down first. Any part you understand, write it down until it can make sense to you. Paul is twice as old as Mary. So if Mary's age is, say, M, then Paul's age will be what? Twice as old as Mary. So Paul will be 2 times M. We establish that. Now, express John's age in algebraic terms. If it is thrice, now thrice is like an old English or so they use in literature. It's the same thing as 3 times. John's age now is thrice. So thrice is 3 times already. Now because the next thing coming is a big stuff, we have to put it in brackets to be able to contain the other statements that will follow. So we've written the thrice, which is this 3 times. The difference between Paul's and Mary's age. Now this difference here, what does he mean? Minus. So the difference between Paul's and Mary's age. And what is that Paul's age? Paul's age is 2 times M, which is the same thing as 2M. And Mary's age is M. So this is the answer. This is the same thing as 3 into the brackets 2M minus M. In further lessons, we'll see how to simplify this further. But this is basically the answer. We've been able to write it. So John's age is 3 into 2M minus M, where M is Mary's age. Here is a try exercise for you to test yourself and see how much you've learnt. Keep an eye on the channel for a solution later on, after you've tried it, of course. Visit our website, mathinfo.com, for so many more exercises like this to solidify your skills and understanding. The next lesson will be on collecting like terms, which is actually the first step in simplification. If you have any word problem, phrase, or sentence, or clause, or whatever that gives you headaches, or you need clarifications from this lesson or from something else, you have comments, you have a feedback, or you have a request, please use the comment section or send an email to ask@mathinfo.com and you will get a response as soon as possible. So this is a wrap on today's lesson. Remember, in mathematics, while you are studying, that it's all connected.